All right, kids, I'm a little confused here. I'm not completely sure what's going on with my recording this morning. Some things are updating and changing, so we'll see if we get this or not. So we're going to start looking at what's known as graphing AX to what power, kids? Second power. Okay, so everything that we're graphing today is going to be to the second power. That's going to be another name for our essential question today. The question is, what are some of the characteristics of the graph of a, what word did I just underline here, kids? Quadratic function of the form f of x is equal to a times x squared. The thing I want you to understand is this. We're going to be focused on that a value. Just understand that a is going to be some number today, all right? A is going to be some number when we look at this stuff today. All right, how about a volunteer to read our goals to talk about characteristics of quadratics of the form ax squared today? Anybody want to do our goals today? I'll read them. First thing we're going to do is identify some characteristics of quadratic functions. And then we're going to graph and use quadratic functions of the form f of x equals what, kids? Ax squared. The squaring of x right here makes this a quadratic. All right, so what is a quadratic function? We're going to talk a lot about quadratics this whole chapter. You're going to hear the word quadratics often. A quadratic is a nonlinear function that can be written of the form ax squared plus bx plus c, but a cannot be what value, kids? 0. Okay, quadratics take on this form, like y, well, this would be called standard form. You're going to be seeing things like y equals 3x squared plus 4x minus 6 as an example. Okay, and if I ask you this question, what degree is this function? What would you tell me?
2.
Degree 2. What's the leading coefficient?
3.
And since that this is degree 2, all quadratic functions are going to be of degree 2. Okay? Now, the shape that they're going to make is called a, what's the word here? Parabola. Probably my favorite mathematical term. All right? If I ever had a restaurant, I'd probably call it Parsons Parabola. Now, you guys know that on the weekends I wrestle, right?
Yeah.
Like, you know what my entry name is? It's the square root of pain. Okay? One of my finishing moves is called the flying parabola. Did you know that, Corbin? Okay, you know what my favorite finishing move is, though?
Soak, yeah.
No, the opposite reciprocal.
Oh my God.
Oh yeah, it's true. You don't believe me? Oh my gosh. What's that? I know you do, okay? I took on The Undertaker the other day. It was great. The U-shaped graph of a quadratic function is known as a parabola. This parabola is basically the shape of the graph. That's a U shape, okay? Or it can also be what else, kids? Like an arch, right? Okay, so those are the shapes you're going to see on graphs today. Okay? Next term, vertex. The vertex is the highest point or the what? Okay. So in this case right here, if it's a U shape, your vertex is at the very bottom here. Okay? And if it's an arch, where's your vertex at, kids? The very top. Okay? So you're going to hear us talk about what's the maximum point or what's the minimum point. And that's going to depend upon if you have a U shape or if you have an arch shape there. All right? Kids, an axis of symmetry. What's an axis of symmetry kind of do to stuff? What's an axis of symmetry do to stuff? Or a line symmetry on that? What's that do to us? Exactly. It cuts it into two symmetric halves, right? Or two equal halves. So an axis of symmetry is going to be a line that passes through the vertex and divides a parabola into what?
2 symmetric.
So if I draw my U shape the best I can, maybe like this. There's my parabola. Here might be a line of symmetry. What point does a line of symmetry have to pass through, kids? Through the vertex. That's a pretty bad line. I'll do a better job here. My line of symmetry might pass right through here at the vertex. But do you agree that the left half mirrors the right half when I fold over that line now? Would you agree with that?
That was part of it.
Good? Okay. So a line of symmetry or an axis of symmetry, they denote this. Sometimes I abbreviate this right here, the LOS, which stands for line of symmetry or axis of symmetry. Okay? Guys, we've talked domain and range before. Domain simply is which values of the function. The x values, the range is simply the what? The y values of the function, and we'll look at that. We've talked about vertical shrink before, but guys, the thing I want to point out today is this. A vertical shrink is going to be a transformation that causes the graph of the function to shrink towards what? Towards what? Okay, what I want you to understand is this. A vertical shrink means moving points of a graph. You're really moving points. Whoops, am I on the right one? Yep. Moving points. Moving points closer to the x-axis. All right, you're moving points closer to the x-axis. So if a vertical shrink meant moving points closer to an x-axis, what do you think a vertical stretch is probably going to mean? Pulling them further away from which axis?
Yeah, I don't know, they just got rid of
All right, vertical stretch. A vertical stretch is going to be a transformation that causes the graph of the function to do what?
Farther away.
Yep, you're going to pull points. You're going to pull points away from the x-axis. Right? And then you guys, you've heard of reflection before. Reflection is just basically a what? Flip over a line, right? You're just going to flip that over a line. That's your job right there. Okay? So I don't think there's anything that's too pressing in the vocabulary today. I think that when you see stuff today, you're going to be like, oh, that's what that means. And I honestly think you probably know a lot of this already. Okay? Yeah, we talked here. I think this section's pretty short. Vocab-wise right now, what questions do y'all have? Give me a thumbs up right now. How many are like, yep, I think I get those terms? Okay, do the illustrations help? Okay, let's roll, page 2. All right, here's what we're really after today, kids. They're going to start talking about identifying characteristics of parabolas. Now again, a parabola is what shape, kids? Parabola's going to be what kind of a shape, really? A U shape. This should really be our school logo right here for Union. Don't you think? I mean,
Definitely.
can you all see the volleyball players running around with this is our school logo? Wouldn't that be cool, Lexi? They'd be intimidated. I'm telling you what, they're like, ooh, these people are good and they're smart too. Think of it, right?
Yeah.
So, all right, let's talk real quickly. Quickly. I said quickly. Why did I say that? I don't know. The first thing you're always going to ask about is what's the what, kids? The vertex is the vertex a high point or low point on this graph? It's a low point, and that vertex is right here. So in this one right here, to identify the characteristics, what is this coordinate, kids? Now I think that these, do you guys agree with me that these boxes jump by how much? 2. So it looks like this point is really right 2 and down how much? 4. So what would that coordinate be for the vertex there? 2 comma negative 4. Okay. Okay, so if I ask you to identify the vertex on a parabola, can you do it? You're just looking for a high or a low. All right. The line of symmetry must pass through which point, kids? It's got to pass through the vertex, doesn't it? Okay, so here's my line of symmetry, maybe right here. I'll just sketch this right here. Guys, isn't that my line of symmetry right in there? Okay. Guys, lines of symmetries for all our parabolas are always going to cross the x-axis. And what x value does this cross at?
2.
Okay, lines of symmetry are always written as x equals, it's a vertical line, 2. Okay? Guys, if I know the x value of the vertex, how does the x value of the vertex compare to the line of symmetry? So what if I told you this right up here? Here's a vertex. My vertex is maybe 8, 22. What's the equation for the line of symmetry to that vertex then, kids? X equals 8, you bet. So if you know the x value of the vertex, then you know the equation for the line of symmetry. It's the same as the x value of my vertex. All right? All right, now we need to talk about where is the graph increasing and where is the graph decreasing. Now, guys, this line of symmetry, I'm going to put a 2 up here. Okay? Guys, how do you read graphs? You read them left to right or right to left, up to down to up? You read them left to right. So if I start over here on the left, kids, and start moving right, is my graph actually increasing or decreasing? Okay, so on the left here, it's actually decreasing. And what's it doing once I get past the vertex? It starts to increase. So I'm going to say my graph is increasing. Is my graph increasing right of 2 or left of 2? So I'm going to say my graph is increasing for x values greater than 2. Where is it decreasing at, kids? So how would I express that? It's decreasing over here for x values that are left of 2 or less than 2. Yeah. Okay. There's a lot of information there, but when I talk about what are the characteristics of a parabola, these are the things they're going to ask you kids. They're going to say, okay, the vertex, 2, -4. The line of symmetry, x equals what? L2. And then this 2 kind of is a divide line to where the graph is either increasing or it is decreasing. Keep in mind, you always read graphs from what to what?
Left to right.
Absolutely. Okay. All right. Example 2 and example 3 are kind of the focal point for this right here. So here's what I want you to do. I want you to make a table like this. And let's go x, and let's go g of x here. And let's go x right here and f of x right here. All right? So in example 2, we are graphing y equals ax squared when what, kids? A is what? Greater than 0. Okay. Well, let's talk about what happens here. Okay? Let's put some points up here for x. Put these points in for me up here. -2, -1, 0, 1, and 2. Do the same thing down here for this x. -2, -1, 0, 1, and 2. Okay, have y'all got those values in for x right there? Okay, we are comparing 2 graphs. One of them is 4x squared to the most basic quadratic of x squared. Okay, let's work with f down here first. Okay, if I threw -2 in for x, what would -2 squared get you, kids? It would be 4. If I threw -1 in, what would -1 squared be? If I threw 0 in, what are you going to get? If I throw 1 in, what are you going to get?
1.
And if I throw 2 in, what are you going to get?
4.
Let's graph f of x here, okay? So the first point I would be plotting would be -2 comma what, kids? Okay, so let me do that. I'm going to blow this up here quickly. Am I in the way?
No, I'm going on the paper.
Is it pretty small? I'm sorry. Are you going to forgive me today?
Probably not.
I guess I won't be coming back for the rest of the year then. Alexis, will you forgive me?
Yes, of course.
Okay.
Nicer than life.
I appreciate that. Guys, when I plot those points, -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4, what kind of shape does it appear to form for us? Is that what we expected? Yeah, we want a quadratic. Now guys, here's what happens. I'm just gonna do my best. I have a hard time sketching parabola, so I'll do my best here to hit those points through the vertex like so, and back up. Where is the vertex, by the way, of that graph? 0, 0. Okay? So that would be your function f. Now guys, let's talk about what happens when we start throwing a values out in front. All right? G of x is not x squared, but rather it is what here? 4x squared, okay? We're going to make some notes about this here in a second, but guys, right here. What would, first of all, okay, maybe I should ask this question. I'm going to throw a value in for x. Do I multiply it by 4 first, or do I square it first? Order of operations would tell you to do the exponent first, wouldn't it? Okay, so what's negative 2 squared still going to be? 4. And then this 4 is going to get multiplied by what value now? I have a question here. Aren't all these values from the original function going to be like the x squared value right here? Can't I just multiply these by 4 to form the rest of this row up here? Or in other words, what's negative 1 squared again, kids? 1 times 4 would be? Where's the next one going to be? If I throw 0 in, what are you going to get out? If I throw 1 in, what are you going to get out? I have a question for you guys. What do you notice about these values? 16, 4, 0, 4, 16. Is there a pattern at all? Around 0, don't those values kind of mirror each other? Okay, so let's try and plot those points. Guys, left 2 and up 16. I don't know where that's at. I'll try and do my best here. Here's 6. It doesn't even go up to 16, does it? In fact, it would be probably way up here. I'm just going to put it way up here about. Okay, what's the next point I can try and get on there? Left 1 and up what? 4. 0, 0 again. Oh, hang on a second. See how this point right here? How far away is this point from the x-axis that I'm pointing at? 1 unit. How far away is this point? This point got moved up how many units? Okay, is this like a vertical stretch or a vertical shrink? I pulled this point away from which axis? This is like a vertical stretch, okay? And then 216 will be kind of way up here. Guys, what I'm going to tell you is this. All right. When a was greater than 0, did we get a U shape or did we get an arch? Got a U shape, okay? So when I get that U shape like that, the point is this. When a is greater than 0, that's kind of like saying a is positive, isn't it? Agree with that? So what ends up happening is this, kids. A couple of things I want you to write down, and this is going to be a big note, okay? If a is greater than 0, which means positive, right? A is positive. You will always get a U shape. Now, 2 things that I want you to write down, and this is going to be very important here, all right? In red, 2 bullets right here. If your A value is more than 1, like I say, who has money on right now?
I do.
If I say I'm going to double your money right now, is that going to increase your value or decrease your value? It's going to increase. So if A is more than 1, this is what I want you to understand. Again, A being greater than 1, it's still what type of a value here, kids? If A is greater than 1, then this is going to be a vertical stretch. But how about if A is between 0 and 1? In other words, like, say, maybe 1/2. What do you think? What if I said I'm going to take half of his money? It'd be a vertical shrink, right? Okay, Logan, fork it over, half of it. Is that a no?
You want $1?
No, I don't. Okay. All right. So kids, here's my question for you. If A is a positive value and it gets a U shape, what do you think A is going to do if it's a negative value? What do you think will happen if A is a negative value?
It'll be a N.
Like an arch type?
Yeah.
Okay. Let's try it. What if ax squared is graph and A is actually less than 0? This should be a negative 1/2 right here, kids. Okay, I don't think that they accomplished what they wanted to accomplish here. Okay, let's talk, kids. That should be negative 1/2 x squared right here. All right, so same game. Let's put up here x and g of x. Let's put here x and f of x again. And same x values, negative 2, negative 1, 0, 1, 2, negative 2. Hey. All right, kids, let's talk about, the f of x will be exactly the same again because it's x squared, isn't it? So let's start with the f down here on the bottom. This will be 4, 1, 0, 1, 4 down here. Okay. But let's go to the negative 1/2 x squared up there, kids. Guys, on my negative 1/2 x squared, what is negative 2 squared? 4. But what's negative 1/2 of 4? Negative 2. All right. Negative 1 squared is 1, right? But what's 1 times negative 1/2 now?
1/2.
What kind of 1/2? Okay, 0 is still going to be what? Okay, if negative 1 was negative 1/2 and this stuff mirrors each other, what's 1 going to be?
1/2.
What kind of 1/2?
1/2.
What's 1 squared again? 1, and then 1 times negative 1/2 would still be negative 1/2 again, right? What's 2 squared on the end? 4, and then negative 1/2 of 4 would be negative 2, all right? Guys, I'm not going to plot x squared again, all right? Because we know, well, what the heck, let's just do it. 0, 0. X squared would be right here. Same U shape again. Kind of like this. All right? Let's plot these other points. So what's the first point to plot for G, kids? Negative 2, negative 2. So left 2, down 2. You all agree? What's my next point? Negative 1, negative 1/2. Negative 1, negative 1/2 about there. 0, 0. Oh my gosh, kids, what is this forming for us? 1 comma negative 1/2 out there. And then 2, negative 2 is right about here. There it is. That might be the best curve of a parabola I've ever drawn free-handed in my life until I had to add on over here. What's a negative out front going to do? It's going to make my shape, a U shape, turn into an, or I always call it the St. Louis arch down there. Yep. Okay. So that's kind of what's going on here, kids. So if A is less than 0, you're going to have, which is a negative value out front, you're going to get an arch shape. And then again, if A is greater than, I should say it this way. If it's like negative 6, would that be a stretch or a shrink? Is 6 bigger than 1 or less than 1? Okay. And then, you know what? I'm not even going to go in there with that. We'll talk about that in a different form here in a second. Okay. All right. You guys okay with that? Okay. All right. Well, let's get this last example ironed out. I'm going to give you a little bit of time working on your big ideas assignment that I sent out today. What questions do you have so far? On board with me? All right, last example. I like this one. So it's pretty simple. Okay, solving a real life problem. It says the diagram on the left shows the cross section of the satellite dish where x and y are measured in what? Meters, okay? You guys see my satellite dish right here on this curve? And this curve is modeled by what function?
Y equals 1/4.
Let me ask a question. Why is this a U shape and not an R shape? Well, maybe let me back up even in front of that. What's the A value for this function? 1/4, okay? Is this, why is this a U shape then? The A value is what again, Allie?
Positive.
The A value is positive, that's why it's a U. How about this 1/4? Would this be something that vertically shrinks or vertically stretches points from the original x squared? Why shrink, Andrew?
Because it's less than 1.
It's a value less than 1, between 0 and 1, good. All right, so we need to find the width and the depth of the satellite dish. Well, guys, the width right here, doesn't this go from here to here for your satellite dish? Isn't that the width? Count, how many units is that? Careful. This is only -2 over to +2. So these units are really going by
4.
a half, aren't they?
Well, yeah.
Yeah, so really how many units wide is this? So the width of that dish is 4. What unit did they use here? Measured in?
Meter.
Okay, so the width would be 4 meters. Okay, the depth has to be the distance from the very top plane up there to the lowest point here. Well, where's the lowest point at, kids? So wouldn't my depth be right here from the top to the bottom here? Okay, so if I was able to fill that dish up completely with water, what would the depth of that water at the deepest point be? You would say, well, it is 1 meter, right? And I just want to confirm something here that we talked about. Just kind of summarizing everything that we talked about in the notes. I'll wait till you have that down. Are you guys okay so far getting that stuff down? Everybody have what they need? I'm just going to jump into decimals again. And decimal is going to become more prominent as we move through this chapter. But just to make sure we're on board here. Guys, if I go in here, I wish I had decimals when I was in high school. You guys don't know how lucky you are. Decimals is the best graphing tool I've ever seen in my life. There's the original x squared. Do you guys agree with that? Okay, what was the equation of that graph again? 1/4 x to the second? If I just type in 1/4 x to the second like this, there it is. Guys, take a look at this point right here, which is at 2 comma what? 4. Go straight down on that vertical line. Does that point move closer to the x-axis or further away onto the blue? It gets closer, right? So if I would say, well, what about what's happening at x equals 2? Well, right here, what point do I have here on the original x squared? You would say it's 2 comma what? What's 1/4 of 4? What's 1/4 of 4? 1. Okay. Does it look like this shrunk closer or got pushed closer to the x-axis right here? And it makes sense that it would shrink because this value right here, is that more or less than 1? One fourth is less than 1, right? Watch what happens here, kids, just to kind of get used to this. If I put in ax squared and add a slider to this, watch what happens. This is pretty cool. The red one's the original graph. I'm going to get rid of this. If I make a values be bigger than 1, are my points pulling away from the x-axis or getting closer? They're pulling away, aren't they?
Is this, in other words, is the blue line going above the red or below the red? It's going above it, isn't it? What if I make A values, say, between 0 and 1? Now where are they at? Above the red or below the red? Below, right? What happens if I make a negative value here? What happens there? Okay. Makes sense to you? Okay, now tomorrow we're going to talk about adding in values of C like this. And we're going to talk about what does C do to this right here. So if I go back, tomorrow it's going to be very simple. The C value, watch the blue graph right here. If I make C bigger, what happens? Slides up. If I make C smaller, where does it go? Slides down. Okay, and we're going to talk about that a little bit tomorrow. So I think you'll catch on to that quickly. All right. So with that in mind, kids, I'm going to stop our recording.